Assalamu alaikum. My name is Sana Saleem, and I have been hired by Valeem as a teacher. I am an IB grad, but I have also done my BSc Honours in Software Development by University of Huddersfield, North England. So my area of specialization lies in computer science, but I can teach students of grade 1 till 8, both of matriculation and Cambridge sections. So today I have selected the topic that is very common, but it's very important as it is a part and participle of our daily lives. So the topic that I have selected is energy. Energy, that means that where does it go? It means that how it changes its forms, basically. So why energy? Energy is basically something that is very much necessary for you people or for me to perform day-to-day activities like running, lifting things, pushing and pulling, and all those things, activities that we do require energy. Without energy, if you don't have energy, so just imagine how you can be. Okay, so in order to understand how energy changes its forms, we have to firstly understand that energy is divided into two main categories. So the first category is energy stores. So what do you actually mean by energy stores? By energy stores, I mean that those sources that actually supply energy or that actually contain or store energy. So the different types or different energy stores like chemical, elastic, gravitational potential, thermal, and kinetic. So if you talk about chemical stores, like for example, the fuel, the batteries, and the food. So why do you actually call them chemical stores of energy? It's because they undergo chemical reaction, okay, when heated, or when, like for example, if your food, if it goes down in your stomach, so different chemical reactions take place, and then after that they provide the chemical energy. So that's why we call food as a chemical store. Similarly, a battery also contains certain compounds or certain chemicals, okay, that after going through some reaction produce electrical energy. In the same way, if you talk about fuel, fuel is a carbon compound, okay? So when it's heated, so it also produces a kind of an energy. So these three, the fuel, the food, and the batteries, they are an example of chemical store. Now, what about this spring? Now, when you extend or when you expand a spring, okay, so you actually kind of storing some energy in it, because like, for example, if you just leave that spring, so it comes to its original position and it also releases a kind of energy. So that kind of energy is called elastic energy. So basically a spring is an elastic energy store. Now, what about this hammer? Now, for example, if you lift this hammer, of course, you require a lot of force. Okay, you have to strive a lot when you have to pick up a hammer. Hammer is quite heavy. So basically, you are also storing a kind of energy. Okay, when you're lifting a hammer, because with that energy, you strike the hammer down, and that energy basically enables the hammer to strike on a nail. So a hammer is an example of a gravitational potential store. Very common example. If you heat something, if you heat, let's say a pan, if you heat a body, a water body, let's suppose, if you give or provide heat to something, so what happens? Okay, so that particular body or that particular thing, it becomes a store of thermal energy. Okay, not heat energy, thermal energy, because the thermal energy is an energy store. It's like still, contained within that body or contained within that store, basically. Okay, so again, a hot body, yes, I would rather say a hot body is basically a store of thermal energy. And last but not the least, the motion, the energy of motion, that is kinetic energy. The energy that enables us to move, okay, is called a kinetic energy. So like, for example, like you can see through this example that a lady is actually riding a bicycle. So how she is doing basically? So what she's doing is like she's supplying her own energy, okay, to the pedals of the bicycle basically. And that energy is converted into kinetic energy that is actually making the bicycle to move. So the energy that enables us to move is basically a kinetic energy store. So this was one category of energy. Now let's come to another category of energy, that is energy transfers. So what are energy transfers? And energy transfers are basically those energies that are actually transmitted. Okay. Now some energies are stored, energy stores, but there are some energies that are actually transmitted. They cannot be contained within. They have to move from one place to another. So the examples of such energies are electrical, heat, and light and sound, because they are very common types of energies, because you know this we have been studying since I think grade 3 or grade 4. Okay, so let us do them in detail. Very common, heat energy. Now, like for example, if like I'm saying, like if a body or a water body is heated, okay, so thermal energy is contained within that body. But if you what happens if you try to pick up this pan and keep it to somewhere cooler, let's say at room temperature, so it starts emitting that energy, it starts transmitting that energy. So the energy that's coming out at that time, okay, that is actually called heat energy. Okay, so this is the difference between thermal and heat energy. Thermal energy contained within, but once it starts transmitting and transferring, so it becomes heat energy. Again, electricity or electrical energy, because since electrical energy is transmitted from one place to another in order to make electric items like fans, ACs, or bulbs to work. Okay, so for that we need electrical energy. So again, it's transmitted because it's transmitted through wires. Okay, so that's why it is also an example of energy transfer. Okay, then we have the sound energy. Now what happens if you bang a drum? A drum then starts vibrating. So when it starts vibrating, so it starts emitting sound energy. It's kind of an energy that then it's reaches our ears, and then we actually hear the bang of the drum. So this sound energy is basically transmitted through vibrations. Okay, so that's why we also say that sound energy is an example of energy transfer. So these three are the main examples of energy transfers. Now comes our main topic, that how energies change their forms. Now look at this example. Can you see an electric switch over here? Okay, so this electric switch, when once I switch it on, once I turn it on, so what happens is that the electricity or electric energy is then transmitted through these wires to this bulb. Then it's like heats the bulb and releases the heat energy. And once more electricity is passed, so the bulb becomes more heated and becomes bright, and thus converts into light energy. So basically, let me show you. This electrical energy is converted or changes, it forms from electrical energy to heat and light energy. Okay, so now this is a very good example that how electricity changes its forms. Now let's look at another example. Can you look at these bulbs? These batteries. Now battery is an example of a chemical store. So once the chemical store, when a chemical store converts its chemicals into electrical energy. Okay, so this electrical energy is then transferred again into the bulb, and then converts into light and heat energy. So chemical energy is converted into light and heat energy. So this is how energy changes from an energy store to an energy transfer. Another very good example is a television. Okay, here in the television, an electrical energy, it passes, inside the television, and then three types of energies are emitted from the television. That is the light energy, the sound, and the heat energy. So again, a very good example of energy changes its forms. Now, what does it prove basically? It actually proves our law of conservation. Okay, what is the law of conservation? That energy cannot be created or it cannot be destroyed. Okay, and energy, okay, it starts from a chemical store, okay, and then again it is converted into an a transfer, and then again it's gone into an atmosphere. Okay, but it's never destroyed. It always remains there until it again becomes an energy store. So basically it's a complete cycle. Okay, so energy is not destroyed or it cannot be created. It has been always there since the beginning of the earth, okay, or the mankind. So it has always been there and it cannot be destroyed. But energy can change its form from one form to another. Okay, like just I explained earlier that from an energy store, okay, it's converted into an energy transfer and vice versa. So this, whatever we have done up till now, actually proves the law of conservation. Now, let me explain with the help of a numerical, or I would say a mathematical representation. Now, you know that energy is measured in joules. Okay. Now, for example, in a television, if 100 joules of electrical energy is input, okay. So what happens is that 50 joules is wasted as heat, okay. 10 joules is emitted as sound energy, and again 40 joules is emitted as light energy. So whatever amount of joules that was input in the television, okay, the same amount of energy is released. Okay, whatever, like 100 joules input, so a total of 100 joules is output as energy transfer. So this also again proves our law of conservation. So that's it, students and parents. I hope that you really like my method of teaching. More or less it will be the same. However, I do believe in strict teaching methodologies, because strict and disciplined, because otherwise our lesson plans will not go accordingly. So if you're interested in my teaching methods, so please contact Valeem, and best of luck, and I'm really looking forward for our association. Thank you so much.